Welcome back to Transcended Institute, the only institute that went to the private school. So in today's session, we are going to look at Math 1120 tutorial sheet 6, that is under exponential and logarithmic functions. Now, what I want you guys to look at is, if you look at these questions, I've solved all the questions from question 1 all the way to question 13, okay? And the solutions are available. So if you want to access the full tutorial sheet solutions, especially for this one and all the remaining ones, you can just register with us and then you'll be able to get access to the tutorial sheet. So let me just show you some of the tutorial sheet that we have and the solutions. You can clearly see that if you go to our website, Transcended Institute, if you just go on Google or Chrome, you type Transcended Institute and then you go on Math, okay? So if you go on Math and then we have got full topic videos and also tutorial sheet as well as past papers. So if you go on past papers, we have got the past papers for 2023, past papers for 2024, full solutions. So if you register with us, you'll be able to access full topic videos, tutorial sheet solutions, as well as past papers for exam and test. So if you want to access the tutorial sheet for 1120, this is the platform. This is the best platform for you guys. So if you click on Math 1120, you'll be able to see all the tutorial sheet from tutorial sheet 1 to tutorial sheet 6. We've got tutorial sheet 1, tutorial sheet 2, 3, tutorial sheet 4. We have tutorial sheet 5 and also tutorial sheet 6. So tutorial sheet 6, if you check here, you'll be able to see that this video is about 4 hours. So I have explained step by step. Okay? So now let us go back and solve some few questions in this tutorial sheet. But like I've said, if you want to access full tutorial sheet solutions, be able to register with us. Okay, so let's start. The first question is saying, given that the function f of x is equal to 1 over 16 raised to the power x, evaluate each of the following. Part A, f of negative 2. Part B, f of negative 1 over 4. Part C, f of 0. Part D, f of 1 over 4. Now let's begin our discussion with the first part A here, which is saying f of negative 2. So what it means here is that where there is x in the function of f of x, we have to put negative 2, and then we need to find the value of that. So our function is f of x to be equal to 1 over 16 everything raised to the power x. So where there is x, they're saying we need to find f of negative 2. So this is going to be 1 over 16 raised to the power x now is negative 2. Now what we have to understand here is that any number to the power negative, let's say we have x raised to the power negative 2, this is the same as 1 over x to the power 2. Okay? Now, if you have maybe 1 over x to the power 3, this is the same as x to the power negative 3. So if I want to remove the 1 on top, I need to put a negative. If I want to remove the negative, I have to put 1 on top. Meaning that what I have here, I can see that this is going to be the same as f of negative 2 is equal to 1 over 16. So I'll say negative that one, I can say I'll first put 1 on top. I'll say 1 over, then I have got 1 over 16 raised to the power 2. I've now removed the negative. Now at this point, I can bring the power inside, where we're going to have f of negative 2 is equal to, I have 1 over 1 squared divided by 16 squared. So I'll do this. Okay, so f of negative 2 now is going to have 1 on top. 1 squared is 1. Now what is 16 squared? So 16 squared is 256. So I'll put 256 here. Okay, now I have f of negative 2 to be equal to, this is the same as 1 divided by 1 over 256. So let's see. I'll get rid of this. Then I'll continue from here to say f of negative 2 is going to be 1 times 256 divided by 1. So my f of negative 2 in that case is going to be 1 times 256 divided by 1 is 256. So in that case, this is my answer. Okay, I'm done with part 1. Part A. So part A, the answer is 256. Let's now go to part B. Part B, they want us to find f of negative 1 over 4. So f of negative 1 over 4, I'll just say negative 1 over 4. Where there is x, I have 1 over 16 raised to the power x. X is negative 1 over 4. Okay, now remember we said where there is negative, if I want to remove negative, I have to put 1 on top. So I'll say f of negative 1 over 4 is going to be, I'll put 1 on top divided by, then I have 1 over 16. This has to be raised to 1 over 4. Okay, now what we have to remember is that if I have x to the power, let's say half, this is the same as the square root of x. If I've got x raised to the power 1 over 3, this is the cube root of x. If I've got x to the power 1 over 4, this is the fourth root of x. So now as we can see, we have got 4 down here, meaning we want to find the fourth root. So in that case, I'm going to say f of negative 1 over 4 is going to be, I have 1 on top, then we need to get the fourth root of 1 over 16. Okay, so now let's get rid of this. Then now we can see that f of negative 1 over 4 is going to be 1. The fourth root of 1 is 1. Then the fourth root of 16, it should be 2. 2 times 2 is 4. 4 times 2, 8. 8 times 2, 16. So I have my 16 here. As we can see, this is the same as 1 divided by 1 over 16. I'll also do what I did in question or in part A, where I said 1 times 16 over 1. So my f of negative 1 over 4 is equal to 16. As simple as that. So in that case, B, 16 is the answer. Now let's go to part C. Part C, they want us to find f of 0. Okay, so f of 0, where there is x, we put 0. So let's see. If I put 0 here, I can see that any number to the power 0 is 1. So my overall answer is going to be 1 for part C. Now let's go to part D. Part D is saying we need to find f of 1 over 2. 1, or it's 1 over 4. So where there is x, we put 1 over 4. Now basically here it's direct. We need to find the fourth root. So it's going to be f of 1 over 4 is going to be the fourth root. This is the same scenario or same case with part B. Only that part B is having a negative where we introduced the 1 on top for us to remove the negative. But in this case, there is no negative. We have just to get the way it is. So it's going to be the fourth root of 1 over 16. Then we can see that 1 over the fourth root of 1 is 1. The fourth root of 16 is 2. So in that case, the answer is going to be 1 over 2. So that is it for question 1. So let's get to see how question 2 is. Question 2 is saying sketch the graph of each of the following function. So this is what we call exponential. So how do we graph exponential? So exponential is in the form of f of x to be equal to a to the power x. As you can see from the questions, we have to the power x. That is an exponential. So we have to know how to sketch an exponential. So let's start with part A. Part A is saying f of x is equal to 5x. So exponential they have got what we call the horizontal asymptote. Okay, then the domain for exponential, the domain is from negative infinity all the way to positive infinity, but the range is restricted, as we are going to see from the graph which we are going to come up with here. So we're going to talk about the domain, but for now what we have to know is that the exponential function, they have got the horizontal asymptote. Now in this case, how do we get the horizontal asymptote? Okay, in this case here we can say there is plus 0. So if there is nothing here, you only have an exponential here, meaning the horizontal asymptote is 0. But in a case where you have something like part B, where it's saying minus 4, meaning the horizontal asymptote in that case is negative 4. Okay, so in a case where I have f of x to be equal to 5x plus 2, meaning in this case the horizontal asymptote is 2. But if you don't have anything plus here, meaning the horizontal asymptote is 0. Now in a case where you have f of x is equal to 2 plus 2 to the power x. Now this is the same as you put this, it has to be here. It's the same, meaning in that case the horizontal asymptote is going to be 2. Okay, so now let's start with the first one. Now there are few steps which you have to follow and exponential, how to graph the exponential function. So the first part is we need to know how to identify the horizontal asymptote. So in this case we don't have anything here, so the horizontal asymptote is going to be 0. Next, I have to equate the numerator, the power, to two things. I have to equate it to equal to 0, so I'll say x has to be equal to 0 and also equal to 1. The reason why we are equating it equal to 0, because we know that any number to the power 0 is going to give us 1. Any number to the power 1 is going to give us the number itself. That's the main reason why we are equating the power into two things. The power has to be equal to 0. The power also has to be equal to 1. After doing that, we have to put the coordinate here. So I have x, y. So now I'm saying x has to be equal to 0 and also x has to be equal to 1. So if x is 0, in this case, if I put 0 here, okay, I can see that my f of x now is going to be what? My y value is going to be 1. Because any number to the power 0 is 1. If I put 1, I'm going to get 5. So I need to have my graph now. So here is going to be my graph. So I'm going to say in x-axis I have got 1. Let me just put, so I have got 1 and 2, also 0. Then in y we have got 1 and 5. So I'll put 1 and 5. But remember, our horizontal asymptote is 0. I'm going to cut a line where is 0, where 0 is. Meaning it has to be running away from this line. We don't know where it's going, but we're going to follow the coordinate which I've just come up with here. So it's 0, 1. So in x-axis is 0. In y is what? In y we have 1. So it's this point here. Then we have got 1, 5. 1 there is there, 5 is here. So coming away from here, running away from the asymptote all the way to here. That is going to be my graph. I have to put the arrow here because I don't know where it is ending. But where it is starting from, we don't put an arrow. But we are putting an arrow where it is going. Now, from the graph here, we can see two things. The domain of the exponential function is always from negative infinity all the way to positive infinity. As we can see from here, the x values, they're starting, we don't know where it is starting from, all the way going there. But the range is restricted. In this case, the range is starting from 0. Okay, so 0 is not included because we are saying that it is running away from that line. So it has to start from 0. It has to start it has to start from 0. So we're going to say from 0 all the way to positive infinity. That is going to be our range. Okay, so that is the graph for the first part. Now let's go to part B. We see what's going to happen there. So part B, we can see that we have f of x to be equal to 5x minus 4. In that case, my horizontal asymptote is negative 4. Okay. Now I have to get the numerator, or I have to get the power. I equate it equal to two things. So x has to be equal to 0 and also x has to be equal to 1. Let's see. So I have x, y. If I put 0, this 5 here is going to be what? It's going to be 1. Now, what is 1? We have got negative 4 here. 1 minus 4 is negative 3. If this is 0, this is going to be negative 3. Let's put 1. If I put 1 where there is x, it's going to be 5 to the power 1. 5 to the power 1 is going to give us 5. 5 minus 4 is going to give us what? So if I put 1, 5 minus 4 is going to give us 1. So let's see. So here is going to be my graph. So in x-axis I've got 0 and 1. So I have got 1. Let me just put 2 as well. Then I've got negative 3 here and also positive 1, positive 1. Now we have to be careful here. The horizontal asymptote is negative 4. So I'll put negative 4 here. Or let me put 3 just to be on top there. I'll put negative 3 here. Then I'll put negative 4 here. So the horizontal asymptote is at negative 4. I have my horizontal asymptote here. Now I'll follow 0, negative 3 is this point. Next is 1, 1. 1, 1 is this point. So now it is running away from the asymptote going there. But let's redraw it. Running away from the asymptote, it has to be going like that. So that is going to be our graph. Now we can see even from here that the domain is from negative infinity all the way to positive infinity, but the range is restricted. The range is starting from negative 4 going to positive infinity. Those are y values. Okay, but negative 4 is not included. So we're going to say negative 4 all the way to positive infinity. That is going to be our range. But the domain of exponential is always from negative infinity all the way to positive infinity. Now the opposite is true when we start doing logarithm. Okay, but we're going to see how. Now let's go to part C. Okay, so part C is h of x. This was g of x, but anyway it's okay even if you use f of x. 5x minus 3. So in that case the horizontal asymptote is negative 3. The horizontal asymptote is just the number which you have here. Oh, this is minus. Here this is supposed to be x minus 3. So we don't have any plus any number here. So the horizontal asymptote in this case is going to be 0 and not negative 3. So it's going to be 0. Now I have to equate this equal to two things. That has to be equal to 0 as well as what? It has to be equal to 0 and also equal to 1. So I'm going to say x minus 3 has to be equal to 0. Again, x minus 3 has to be equal to 1. Then solve for x. Let's start with the first one. So the first one, x will be equal to, if I shift x to the other side, it's going to be equal to 3. Another one is going to be, if I shift this x, this negative 3 to the other side, is going to be plus. So x will be equal to 4. So we have two values of x now. Okay, what I'm trying to say here is this. You get the whole of this. Okay, you get everything here. The power which you have, equate it equal to two things, 0 and 1. Solve for x. So the first part here, let's start with the first one. I've equated equal to 0. So I'll say x is equal to 0 plus 3. My x will be equal to 3. Let's now get rid of this. So our first x has to be equal to 3. X is equal to 3. Now another one, we have to equate the same thing equal to 1. So I'll say x minus 3 is equal to 1. X is going to be equal to 1 plus 3. X will be equal to 4. That will be our second value of x. So my x will be also equal to 4. Now let's see what we're going to have, the coordinate. So we have xy. If x is 3, what will be the value of y, and if x is 4, what will be the value of y. Let's see. Now if I plug in, I have got 5 to the power, if x is equal to 3, it's going to be 3 minus 3 is going to give us 0. If so, any number to the power 0 is 1. So if x is equal to 3, y will be equal to 0. What if when x is 4? So it's going to be 5 to the power 4 minus 3, which is going to be 5 to the power 1. So any number to the power 1 is the number itself. So in that case, 5 is going to be our y value if x is 4. Now let's put it here. Want to graph it. So our horizontal asymptote is 0. I'll cut a line here where there is 0. Next, what I'm going to do is I have got in x-axis I've got 3 and 4, but what I can do is I can put 1. Let me use different column. I can put 1, 2, 3, 4, 5. So I have got 1, 2, 3, 4, 5. But even if you put just 3 and 4, it's okay. Then in y-axis I'll just put 2. I've got 1 and 5. So I'll put 1 and 5. But if you want, you can put 1, 2, 3, 4, all the way up to 5. That is just okay. Even here I can put some numbers. It's okay. So now I'll say 3, 1. I have got 3 in x-axis, 1 is this point. Then 4, 5. 4, 5 is here. This point here. So running away from the asymptote, all the way going there. So the straight line has to be like this, running away from the asymptote, going like that. That is going to be our graph. Even here, as we can see, the domain is from negative infinity all the way to positive infinity. The range is from 0 not included because it is running away from the asymptote all the way to what? All the way to positive infinity. Okay, that is for question 2. Now let's see how we can solve question 3. Question 3 is we're talking about the same thing. We want just to sketch the exponential, but in this case we have different ones. So the first one is f of x to be equal to 1 over 3x. We are using the same principle. X, in this case, the horizontal asymptote, we don't have anything. Horizontal asymptote is 0. So x has to be equal to two things, 0, x has to be equal to 1. Okay, so here I'll have x, y. I'll say if my x is 0, what will be my, if my x is 0, what will be my y? Is 1. Any number to the power 0 is 1. If my x is 1, what will be my y? My y will be the same 1 over 3 because any number to the power 1 is the number itself. So that is what we have there. Now let's see how we can sketch it. So I'll have my graph here. I'll have my graph, then I have two coordinates. As we can see, I have okay, so let's do it from here. We sketch it. Okay, so in x-axis we have got 1 and 0, so I'll just put 1 here and 2. So let's just put 1, 2. In y-axis we have got 1. Okay, we have got 1. So we have got 1 has to be, we have got another number here which is 1 over 3. 1 over 3 I can put it here because 1 over 3 is 0 point something. So and then I'll put 1 here. So the first is 0 comma 1. Where is it? 0 comma 1 in x0, so it's this point here. Let me use different color. Then the next one is 1 comma 1 over 3 is this point. But remember, it is the horizontal asymptote is at 0. So in this case now it is running away from the asymptote, but it has to go in that direction. Okay, so even here we can see that the domain is from negative infinity to positive infinity. The range is from 0 not included all the way to positive infinity. That is it for part A. Now let's go to part B. Part B in this case is saying we have f of x, although it's g anyway. Let me put g. We have 1 over 3 x plus 2. Now here we have got plus 2, that is definitely our what? Horizontal asymptote. So our horizontal asymptote in that case is positive 2. Okay, that is our horizontal asymptote. Now after identifying the horizontal asymptote, that is going to be very easy now. So we're going to have is 2. So I'll put my horizontal asymptote 2. I put the power, I equate the power equal to two things, 0 and 1. Okay, so I'll do this, xy. We can see that if x is 0, so it's going to be 1 over, it's any number to the power 0 is going to be 1. 1 plus 2. So if x is 0, 1 plus 2 is 3. If x is 1, so here I'm going to get 1 over 3, if that is 1, okay, plus 2. It's going to be the same 1 over 3 plus 2. So here I can just say if x is 1, what would be the value of 1? So I'll say the common denominator is 3. 3 into 3, 1. 1 times 1 is 1. Plus 2, 1 into 3 is 1. 1 into 3 is 3. 3 times that one is 6. So I'm going to have a 7 over 3. So it's going to be 7 over 3. If x is 1, y is going to be 7 over 3. Another method which you can use from here, you can just say this to make things simple. You just do this. 1 over 3 plus 2. This is the same as times 3 divided by 3. Because this and this, they will cancel. So it's the same. Then we're going to say we have 1 over 3 plus 2 times that one is 6 over 3. Then the denominators are the same. I'll add the numerator, 7 over 3. Okay. Now from there, let's now see how we can graph this. So I'll have my graph here. So I have my vertical asymptote at 2. So let me just do this, which is the horizontal and not vertical. So I'll say I'll have my 2 here, my 7 over 3, then 3. So I'll have my 2, then here I'll put 7 over 3. We know that 6 over 3 is 2, so that one is going to be 2 point something, which has to be bit on top of 2. So we are going to have 7 over 3. Here we have 3. So the horizontal asymptote is at 2. So I'm going to cut here. This line, that's where there is our horizontal asymptote. So now in x-axis we have got 0 and 1. So I'll put 1 here. Now we can clearly see from here that we have 0, 3 is this point. Then we also have a 1, negative, that point is this point here. So we can clearly see that it's running away from the asymptote, touching in those areas. That is going to be our graph. As simple as that. Okay. Now let's go to part C. So part C, you can pause the video, try to sketch it, and then see how we are going to solve here. So we have our function f h of x to be equal to 1 over 3 to the power x plus 4. So just get the power, equate it equal to two things. Since we don't have anything here plus anything, definitely our horizontal asymptote in that case is 0. Now that we know our horizontal asymptote and we have also equated that to two things, let's now see what we can do. So we're going to say x plus 4 has to be equal to 0 and x plus 4 has to be equal to 1. Let's solve for x. Let's start with the first one. So the first one, I can see that x plus 4 is equal to 0. X will be equal to 0 minus 4, and x will be equal to negative 4. Okay, another one, the second one is x plus 4 is equal to 1. So x plus 4 will be equal to 1 minus 4. So x will be equal to negative 3. Now that we have the values of x, let's see how we can find the values of y. So I'm going to have my first x to be equal to negative 4 and my another x to be equal to negative 3. I'll get rid of this and come up with just a simple coordinate. So I'll have this x, y. So if x is negative 4 and if x is negative 3, what will be the value of y? Let's see. So 1 over 3, x has to be negative 4 plus 4. So negative 4 plus 4 is going to give us 0. So we have 1 over 3 to the power 0. Any number to the power 0 is 1. Now what if we put negative 3? Let's say where there's x, let's put negative 3. I'll have negative 3 here. Then I'm going to have 1 over 3 is going to be negative 3 plus 4 is 1. Any number to the power 1 is the number itself, 1 over 3. Okay, we end there. Now from here I can now graph this. I'm going to say here is my graph. My horizontal asymptote is 0. That line has to cut here because that is my horizontal asymptote. Okay, I have negative 4, but since I have got negative, let me just do this. I put this one on top just a bit. Okay, then I cut now. Okay, so I'm going to have in x-axis I've got I've got negative. In y-axis that's where I've got positive. I was thinking maybe this negative they are there on negative on y, but anyway, let's just put it here. Let's just put them here. So I'm going to say let me put negative 3 here and negative 4 here. If you want, you can put negative 1, 2, 3, 4 up to negative 4. That is just okay. Here I can put negative 1. Oh, I can put 1, not negative. Here I can put 1. Here I can put 2. Then in y-axis I've got a negative or 1 over 3 and a 1. Okay, so now from our coordinate we have got negative 4 comma 1. Negative 4 comma 1 is this point. Then we also have negative 3 comma this is that point. Now we can see that the horizontal asymptote is at this line. It has to run away from that line going in that direction. Running away from the asymptote, so it has to touch these two. So running away from the asymptote all the way there. So that is going to be our graph. So that is it for question 3. Let's see how we can do question 4. Question 4, we are still talking about graphing exponential. But in this case, we have got an e. E is just basically 2.718, somewhere there. It's a number which we have to know. But now, since we are not using calculators, we are going to be using the same e. But I'm just giving you a hint to say e is a number which is approximately 2.178, somewhere there. It's just a number, which if you want you can know it, but just know that it's a number. So now I'll start with part A, which is saying f of x is equal to e to the power negative x. Remember, we don't have anything here, so the horizontal asymptote is definitely 0. What else? We equate the power equal to two things, equal to 0, equal to 1. We can see that x will be equal to 0 and x will be equal to negative 1. As simple as that. So I can now get rid of this. I'll have my simple coordinate x, y. If x is 0 and if x is negative 1, so let's start with negative 1. If x is negative 1 and x is 0, what will be the value of y? So let's see. E raised to the power negative. If x is 0, it's going to be 0 anyway. So it's going to be e to the power 0, which is going to be 1. Any number to the power 0 is 1. Okay. Now next, if x is equal to, oh anyway, let's start with -1. Sorry, we start with -1. I started with 0, so if I start with 0, meaning that 1 has to be here. So let me start now with let me now go to -1. Negative, if I put -1, this is going to be e to the power 1. So e to the power 1 is just basically e. Okay, now from here we can have our graph. In x-axis we have got -1 and 0. In y-axis we have got e. So we have got 1 and e. Just put e. E is a number which is 2.178, somewhere there. So we know that e is a bit bigger than a, or we can say greater than a. So what we're going to do now from here is we'll start -1 comma e. It is at this point. -1 is here, e is here, so it is here. Then you have 0 comma 1 is this point. Remember the horizontal asymptote is 0, so it has to cut this line. So running away from this line, going there, that is going to be our graph in that case. So that is it. Now from here we can also see that the domain is from -infinity all the way to +infinity. The range is from 0 all the way to +infinity. As simple as that. So now we are done with part A. Let's go to part B. Part B, we have g of x, which is e to the power x plus 1 minus 2. Remember, the horizontal asymptote is the number which you have here, which is not an exponential. So the horizontal asymptote is -2. We equate this equal to two things. So we have got x plus 1 is equal to 0, x plus 1 is equal to 1. Let's solve for x. Let's start with the first one. So we have got x plus 1 is equal to 0, x will be equal to -1. I'll put it here. Next, I have x plus 1 is equal to 1, x will be equal to 1 minus 1, so x will be equal to 0. So x will be equal to 0. We are done with that. Now, I'll come up with the coordinate. We see how we can get it. I'll have this. If x is -1 and if x is 0, what will be the value of y? Let's see. E to the power -1 plus 1 minus 2. So this is going to be e to the power 0 minus 2. Any number to the power 0 is 1. Minus 2 is going to give us -1. So I'll get -1 here. I'm done with that. What if it's 0? If x is 0, what will be the value of y? So we have got e 0 plus 1 minus 2. So e will be equal to the power 1 minus 2. So it's going to be e minus 2. So you just put e minus 2 because we don't use the calculator here in this case. So e, we are saying, is approximately 2.17, somewhere there. Okay, so we expect this one to be e minus 2 to be 0.178, somewhere there. Okay, so what I'm going to do now is I'm going to have my graph. I'm going to say, here is my graph. So I have this. My horizontal asymptote is going to be at 0. Okay, it's going to be at 0. So I'll do this. Oh, it's at -2 and not 0. So let's put our -2 here. Then we also have -1. We also have, at this point, we're going to have e minus 2. Since e minus 2 is going to be about 0.178, somewhere there. So our horizontal asymptote is at -2. It has to start running away from that line, going up. So now we have the first point, which is -1, -1. I'll put -1 here. So it's this point. Next is 0, that point, this point. So running away from the asymptote, going there. That is going to be our graph. So the domain of this is always negative infinity to positive, but the range is always restricted. In this case, from negative 2 not included all the way to positive infinity. So that is it for this question. Let's go to part C. We go to part C. We see how we can solve part C. So part C is h of x is equal to e raised to the power x minus 4 minus 1. The number which you have, the one which is not having the power, that is our horizontal asymptote, negative 1. We get the power, we equate it equal to two things. X minus 4 is equal to 0, x minus 4 is equal to 1. Let's solve for x. Another one is going to be x will be equal to, if I shift 4 to the other side, it's going to be 4. Again, if I shift 4 to the other side, it's going to be negative 3. Okay, so I have this x, y. So let's see. If x is 4 and if x is negative, oh, this is going to be plus now. It's going to be 5 because we have got x minus 4 is equal to 1. So it's going to be x plus this. So this has to be 5. So if x is 4 and x is 5, what will be the value of y? So I'm going to have e raised to the power, our x is 4, 4 minus 4 minus 1. So I'm going to have e raised to the power 0 minus 1. So what is e raised to the power 0? Any number to the power 0 is 1. Okay, so I'm going to have 1 minus 1, which is going to be 0. So I'll have my 0 here. Next, I'm going to say 5. If I put 5 where there's x, what would be my value of y? So it's going to be e raised to the power 5 minus 4 minus 1. So it's going to be e raised to the power 1 minus 1. So just say it's going to be e minus 1. That's all. And e, we said, is approximately 2.178, somewhere there. So now let's have our graph. So here is going to be our graph. So in x-axis I have got two things. I've got 5 and 4. Let me just put it like this. I have a 5 and 4. So I have 5, or let's start with 4. 4 and 5. Okay. Remember, our horizontal asymptote is at negative 1. So here is going to be my negative 1. That the graph is starting running away from negative 1 going up there. Let's see. We have got I'll put my e minus 1 here because e minus 1 is going to be approximately 1.178 somewhere there. So let's see. We have got 4 comma 0 is this point, 5 comma this point is this point, 5 comma e minus 1, running away from negative 1 going there. That is going to be our graph. So that is it for question 4. Now let's see how we can solve question 5. So question 5 is saying, rewrite each of the following expression in exponential form. Now how do we write from log to exponential? Okay, so now I have the first one is log base 1 over 6 of 36 is equal to negative 2. Now from here we can say that we want to come out from log to exponential. Now this is simple. You get the base has to be equal to what is there, then the base has to be equal to what is outside. So we say the base raised to the power what is outside is equal to what is inside. So we're going to say 1 over 6, I put them in brackets, raised to the power negative 2 is equal to 36. That's the meaning. And for sure, if we can prove this, this is going to be true. So we are saying the base raised to the power what is outside is equal to what is inside. So in this case, 1 over 6 is the base. So we have to raise what is outside, which is negative 2, has to be equal to what is inside, which is 36. And for sure we can prove this because this is 1 over 6. If I put negative 2 here, are we going to find 36? Yes, of course. So we're going to say, if I want to remove negative like we have said in question 1, we're going to say this. So this is going to be to the power 2. So we're going to have 1 over we're going to have 1 over 1 over 1 squared is 1, then 6 squared is 36. So it's going to be 1 divided by 1 over 36. So it's going to be 1 times 36 over 1, which is 36. It's true. So now coming from log to exponential is very easy. Now I have got question 2 here, which is saying, which is part B, is saying log base 12 of 20,736 is equal to 4. What it means here is that we want to come out from log to exponential. The base raised to the power what is outside is equal to what is inside. So in that case, it's going to be 12 raised to the power 4 is equal to 20,736. This is now an exponential. Okay, and for sure, if you say 12 raised to the power 4 is going to give you 20,736. Okay, let's now go to C. C is saying log base 9 of 246 is equal to 5 over 2. So this is just 9 raised to the power 5 over 2 is equal to 2000 or 243. That is now an exponential. Okay, we are coming out from log to exponential. But D is saying log base 4 of 1 over 128 is equal to negative 7 over 2. So the base is 4. 4 raised to the power what is outside is equal to what is inside. So it's going to be 4 raised to the power negative 7 over 2 is equal to 1 over 128. As simple as that. Now the last one is saying we have log base 8 of 32,768 is equal to 5. So this is just supposed to be 8 raised to the power 5 is equal to 32,768. That is now an exponential. Now that we know how to come from log to exponential, now let's see the next question, which is going to be talking about coming from exponential to log. Now remember here, what we have here, for example, let me just give you this one example here. Okay, let's say we have 2. This is just a simple example. Let's say we have 2 to the power 3 has to be equal to 7. In that case, that is just a simple example. Now I want to show you to come out from exponential to log. Okay, so we are saying, let's say we have 2 raised to the power 3 is equal to 6, or let me say 8. Okay, now if we can check from here, the first one, this one is always the base. This is going to be what is equal to, this is what is going to be inside. So in this case, it's going to be log. If I want to come out from exponential to log, it's going to be log base 2 of 8 is equal to 3. Because if I want to come out from this to exponential, I'm going to say 2 to the power 3 is equal to 8. Now this is what question 6 here is saying, rewrite each of the following expression in logarithmic form. So now what we have to know here is that we said the first example which I've just given you is this. If we have 2 to the power 3 is equal to 8. If I want to write this into log, is log. This is always the base. So this is going to be base 2 of 8 is equal to 3. Because if I want to come out from this to exponential, is 2 raised to the power 3 is equal to 8. Now I have got the first one here, part A, which is 11 raised to the power negative 3 is equal to 1 over 1331. Meaning I'm going to say log what I have here. This is my base. It's going to be this. Then this is what is inside. So it's going to be 1 over 1331 is equal to negative 3. Now I've come out from exponential to log. Okay, let's go to part B. Now part B is saying we have 4 raised to the power 7 is equal to 1633 or 16. Then I've got 3 then I've got 84. Okay, remember this is always the base, so base 4, this is always what is going to be inside. So I'm going to have 16 384 is equal to the power, meaning if I want to run away from log to exponential, it's going to be 4 raised to the power 7 is equal to 16,384. Okay, now you can do part C. So part C is 2 over 7 raised to the power negative 3 is equal to 343 over 8. So log, this is going to be log base negative base 2 over 7, then 343 over 8 is equal to negative 3. As simple as that. Let's see how we can change part D, which is 25 raised to the power 3 over 2 is equal to 125. So this is log base 25 of 125 is equal to 3 over 8. Okay, the last one is saying a 27 raised to the power negative 5 over 3 is equal to 1 over 243. So this is log base 27 of 1 over 243 is equal to negative 5 over 3. So now this is what we need to know, how to come out from log into exponential, as well as from exponential into the into log. So that is very, very important. Question 7. Determine the exact value of each of the following without using a calculator. So how do we tend to determine the exact value of a log? So here's our question A, which is saying we have log base 7 of 343. Now, before we solve these questions, I want us to understand the basic rules of a log. So let's say we have log base A of B k. So what it means here is that I can shift this to be in front of log. So this is the same as k log A of B. So now let's assume to say we've got the same things, and let's say we have log base A of A raised to the power x. I want to find the exact value of this. So now we are saying that the property of log allows us to shift this power to be in front. So I'll say this is x log A of A. So if you have got log of anything base of itself, that is definitely 1. Okay, so for example, this part here is going to give us 1. Then we're going to say 1 times x, in that case is going to be x. Now let's see. I have the first question, which is log base 7 of 343. Now this 343, how can we make it? We need to make that 343 to be 7 to the power a number, so that 7 and 7 should give us 1. Now if we do 7 to the power 3, okay, 7 to the power 2 is 49. Now 49 times 7 is going to give us 343. So meaning that this is going to be log base 7 of 7 to the power 3. Now the property of log allows us to shift the power to be in front. I'm going to have 3 log 7 of 7. This part here is going to give us 1. So we're going to have 3 times 1, which is going to be 3. So the exact value of this is basically 3. Now let's go to part B. Part B, we have log base 4 of 10, 10, 24. Now, how can we make it? If I do 4 to the power 4, if I do 4 to the power 2 is 16. 16 times 4 is going to give me 64. 64 times 4 is going to give me 1024. So in short, what I'm trying to say, 4 raised to the power 5. So I'm going to say log base 4 of 4 to the power 5. If you do 4 to the power 5, it's going to give us 1024. So the property of logs, I'm going to shift 5 here, log 4 base 4. So this part is going to give us 1. Without using a calculator, we can see that we're going to have our answer to be 5. Now, there's another method which we can use apart from this one. Now, I'm going to show you. So, let's say we have, okay, let's use another method. If you want, you can equate this one equal to x. Okay? Say this is equal to x. Now, you can convert this into exponential where we're going to say 4 raised to the power x is equal to 10, 24. So this is going to be 4 to the power x. This I can change it so that the base should be the same. This is going to be 4 to the power 5. So 4 and 4 will cancel, x will be equal to 5. So in this case, the exact value is 5, if you want it that way. Okay? Now, if you want, you can do it direct like the way I've done it. Now, let's go to part C. Part C is saying we have log 3 over 8 base 3 over 8, then we'll go 27 over 512. If I want, I can equate it to x and then find the value of x. That is the exact value. But again, if I want, I can do it direct from here. I know that log 3 over 8, this 27 is the same as 3 to the power 3. Then again, 512 is the same as 8 to the power 3. So I can write this and say it's log base 3 over 8. Then I say 3 over 8 to the power 3. I can shift 3, which is the power, to be in front. It will be 3 log base 3 over 8 of 3 over 8. Meaning this part is going to give us 1. This part here. So it's going to be 3 times 1, which is 3. Okay? So the answer in that case, part C, is 3. Let's go to part D. Part D, we have log base 11 of 1 over 1.1. If you want, we can equate it equal to x and find the value of x. That is the exact value if you want. So I can say x 11 raised to the power x is going to be equal to 1.1. But here there's 1 on top. Now I can say 11 over x is going to be equal to 121 is the same as 11 to the power 2. Now 1 over 11 to the power 2 is the same as I say 11 over x is going to be equal to 11 to the power negative 2. So this, the bases will cancel, x will be equal to negative 2. Meaning that the exact value of log base 11 of 1 over 121 is negative 2. But again, I can use the property of log to find the exact value without using a calculator. So there are two methods. You choose which one to use. You end up having the same answer. Now let's use the second one, like the first formula, 1 over 121. So this is going to be log base 11. 121 is the same as 11 to the power 2. Okay? So now this is 1 on top. It's the same as log base 11. Then I say 11 to the power negative 2. The moment I say negative, meaning this one has disappeared. Like the way we did on question 1. Yes. So now I can shift negative 2 to be in front. 11 of 11 is going to give us 1. So the answer is going to be negative 2. Okay. Now let's go to part E. Part E we have log base 0.1 of 0.0001. But again, this is the same as if I say log 0.1, then I say 0.1. If I raise it to the power 4, it's going to be, as we can see, we have got 1, 2, 3, 4. So it has to be raised to the power 4. So 0.1 raised to the power 4 is going to be 0.0001. If you want, you can use that other method. That is just okay. So this is going to be, I can shift the power to be in front, 4 log 0.1 of 0.1. So this part is going to give us 4 times 1. The answer is 4. That is the exact value. If you want, you can use that other method where you equate it equal to 0. You find the same answer. Okay? You equate it equal to x, sorry. So what is f? F is log base 16. Now, this one, you can only use one method. Anyway, there are some other methods which you can use, but for me here, I'm going to show you one method on how to solve this one. It is impossible for us to, unless if it was log base 4 of 16. You can say 4 is the same as 4 to the power 2. But in this case, we have to equate this equal to x and solve for x. That is going to be the exact value. So I'm going to say it's going to be 16 raised to the power 16 raised to the power x is going to be equal to 4. I've changed now from log into exponential. Now, after changing from log into exponential, now we can solve this. Now, we know that 16, to make the bases to be the same, is going to be 4 raised to the power 2. Then this is the same as 4 raised to the power 1. So this is the same as 4 raised to the power 2x is equal to 4 raised to the power 1. The bases are the same, we can cancel them. 2x is equal to 1 divided by 2 divided by 2, x will be equal to 1 over 2. So in that case, the exact value is 1 over 2. As simple as that. Now let's go to part the next one, which is part G. G is saying log if you have not been given any base, meaning that is base 10 always. So in this case, we don't have any base, meaning it's base 10. So it is 10,000. So that is definitely the base 10. Okay? If I want, I can equate it equal to x, solve for x. Or if I want, I can just do it direct. So I'll say this is base 10. So it is log base 10. 10 to the power 3 is going to be 1000. But in that case, it has to be to the power, it has to be to the power 10, to the power 4. Because we have got 4 zeros, 1, 2, 3, 4. So it has to be to the power 4. So it's going to be 4 log 10 of 10. So these, they will give us 1. So it will be 4 times 1, which is 4. So the answer in that case is going to be 4. But if you want, you can also use, you equate it equal to x and solve the value of x, where you are going to say this is equal to x. So it's going to be 10 raised to the power x is equal to 10,000. I make the bases to be the same, so it's going to be like this. 10 raised to the power 4, the bases will cancel, x will be equal to 4, meaning the exact value is 4. Okay, so we have the last one. The last one is ln. Now they have given us a natural log, so we have ln 1 over the fifth root of e. Now ln is always in base e, but they will not show, it's the same as log. If they not give you any base, just know that it's in base 10. Okay, so same as natural log. Natural log is always in base e. So here what we have to mind is that here there is e, but they don't just show it. Okay, so in this case it's going to be ln 1 over the fifth root. If I have the square root of e, this is the same as e to the power half. If I've got the cube root of e, this is the same as e to the power 1 over 3. If I've got the fourth root of e, this is going to be e to the power 1 over 4. What of the fifth root? This is definitely e to the power 1 over 5. Now, if I've got e to the power 1 over 5, what we have to know now is e to the power 1 over 5. I have got 1 on top. If I want to remove that one, I can say it is e raised to the power negative 1 over 5, meaning this one has disappeared, like the way we did in equation 1. So now I have got ln e, remember it is in base e, negative 1 over 5. I'm going to say this, I can shift the power to be in front, negative 1 over 5 ln e. Remember this is base e, so base ln e of base e is 1. So I'm going to say the answer is negative 1 over 5. As simple as that. So that is it for question 5, for question 7.